Subscribe to our channel and press the bell icon to never miss any update from CreateUp.
Hello everyone, hope you all are doing good and preparing well for the examination. And as this is the time to practice as much questions as you can and solve a lot of question papers for the exam. And let's discuss about the JEE Main 2017 question paper solution. So this, we have already done a couple of screencast videos. First we discuss question number 1 to question number 10, then 11 to 20th. If you haven't watched those videos, go back, watch them, then can come to this screencast session. And in this screencast video, we'll be going to discuss from question number 21st to question number 30th. So this is Surya Dwivedi telling you all about chemistry. Let's start up with the session. So in this set of questions, you have a fairly even distribution of questions. You have easy questions as well as you have medium questions, and there are a couple of tough questions as well, because most of the questions in this part consist of organic chemistry questions. So they can be a bit tough for you because you haven't seen the exact compound before. And if you don't have the concepts ready with you, if you have all the good concepts with you, you are very fluent with the compounds and how which reagents acts in what way, then you'll be able to fairly solve this question. So yep, let's start up with the video. So now in the 21st question, which of the following compound will form significant amount of meta product? So a significant, it's not major or minor, but a significant amount of meta product during the mononitration reaction. So what is a mononitration reaction? You have a HNO3 and you have H2SO4 here. So you get kind of NO2 plus ion substitution. So this is a mononitration reaction, and it's actually electrophilic substitution. The reagent needs the the electron pairs. So what happens generally, you can see all the compounds which are given in the options, they all have a lone pair here. The the atom which is attached to the ring all has a lone pair here. So what you expect generally, the lone pair will go down here, and then the bond shifts and you get a high electron density at these ortho and para positions in all compounds. But since we have this reagent and it's like a acidic environment inside the solution, so what happens generally with this amine? What happens here, this basically tend to form, tend to get attached with hydrogen and form this thing here, NH3 plus and HSO4 negative, right? It tends to form this kind of a compound when it gets into the solution. So in this case, what happens now, the lone pair of nitrogen is not freely available to increase the density at ortho and para position. And this does not happen with OH, because it's again phenol is kind of acid and it's going to the acidic solution. Doesn't happen with it. Doesn't happen with OCOCH3. You can fairly argue that this can happen with NHCOCH3, but again it's not the case. Why? Because the electron pair of N is not freely available to get attached with H plus ion, because it is getting resonated here inside the ring as well as with the carbon attached to it, because the carbon attached to it also has a double bond with oxygen. So the lone pair is not as freely available as in case of aniline to get attached to the H plus in the acidic solution. And when it gets attached to the H plus in the acidic solution, that moment, that's the case, finalized, no more lone pair available to to get inside the ring. So in this case, it's a highly deactivating group. So what happens, that the meta position start becoming favorable, and the meta position is in fact more favorable than the ortho position. There is a competition between meta and the para position, but meta position is significantly favorable in case of this compound. So your correct option for this question is A part. Moving on to the next question. Which of the following upon treatment with tertiary butoxide ion followed by addition of bromine water fails to decolorize the color of bromine? Fails to decolorize the color of bromine. What does that mean? Alright, fails to decolorize the color of bromine means it doesn't have a double bond, right? It doesn't have a double bond, right? You should understand it fails to decolor. If double bond is there, then it decolorizes. Okay, and by double bond we don't mean the the aromatic double bond. We just mean the double bond outside it. All right, so tertiary, this butoxide ion, okay, so it's a bulky reagent. What kind of reagent it is? It is a bulky nucleophile. So it can give a substitution reaction. All right, substitution reaction as well as a elimination reaction, right? And there is always a competition between substitution and elimination, and whenever there is a competition, always elimination will be favorable. If there isn't a competition, then the substitution reaction will take place, and if there is a competition, then always the elimination reaction will be favored over the substitution reaction, because it's a bulky base. For it to attack, to substitute, it needs space. All right, so let's see the compounds one by one. So here what we have, we can have elimination reaction here, because if the bromine leaves and forms a carbocation, we have an alpha hydrogen which can be taken away by this tertiary butoxide ion, and there we can get a double bond here. The bromine will leave and we can get a double bond here. Same case here, we can get a double bond here. In the last option, if the bromine leaves, we can get a double bond here. It's highly favorable because it can resonate here as well as here. Okay, so this will be the product in this reaction. But if we try to leave this Br, then there is no alpha hydrogen. There are two hydrogen present here, but there is no alpha hydrogen here, no alpha H here for for butoxide ion to give you the elimination reaction. Okay, so since there is no such kind of ion here, so you get which kind of a reaction? You get a substitution reaction here. All right, so when you get a substitution kind of a reaction here, then you don't get a double bond and you fail to decolorize the color of bromine. What substance eventually forms if we are going to get a hemiacetal or hemiketal or something like that, then the chain breaks or something happens, we don't need to worry about it. What happens after the reaction, we don't need to worry about it. We just need to know that there isn't going to be a double bond, so it fails to decolorize the color of bromine water. Okay, so hence the C option is correct, because rest all the options we are going to have a double bond. Now the 23rd question. The formation of which of the following polymers involves hydrolysis reaction? So now we need to see these polymers and we need to know what kind of reaction these like how they are made, and then because in this polymers chapters, these are the famous polymers, these are the stars of polymers, so you need to know the preparation of every polymer in order to give the exam. Obviously you have to you have to have it on your fingertips. So I'm just going to elaborate. So these can be addition polymers or or condensation polymer, but I'm just going to tell you about the polymer which actually gets formed by the hydrolysis reaction. The answer is nylon 6. And how does it forms? It is being formed by caprolactam, right? And what's caprolactam? How does it look like? So you have an N here, and then it's a 7 carbon ring. All right, so I guess I'm making it right. So it's like 1 carbon, 2 carbon, 3 carbon, 4 carbon, 5 carbon, 6 carbon, and nitrogen. So it's a ring with 7 atoms all together, and adjacent to the nitrogen you have a carbon with double bond O, and there will be a H attached to the nitrogen. Now this caprolactam actually goes hydrolysis, right? Hydrolysis, it goes hydrolysis. So this bond goes hydrolysis, and yep, you are right. You get a H here for this. It has a H already, so you get another H plus here, and you kind of get a OH here. So what happens now, you formally get this NH2 here. In fact, I'll tell you, it'll form a Zutteran kind of a thing. So you eventually get at the starting, if you hydrolyze it, it's a NH2, and then you kind of get 5 carbons in the middle, right? If you take it like this, then you get like CH2 and 5 times, and then you get C double bond O OH here, and then eventually this kind of ion can form a Zutteran. So you get like a H plus here, so this will form NH3 plus, and this will be, because it's an acid base kind of a thing, right? And after that, this compound goes polymerization, right? This compound goes through polymerization, and you eventually end up forming your NH, right? And then this CH2 5, and then this COO. Yep. So this is finally your nylon 6, which you form here. Okay, so this is the way you form nylon 6. This is the correct option, because in the first step of forming nylon 6, you are having hydrolysis. All right, so here the C option is correct. You can know that like the terylene is formed by the condensation, polymerization, or something. You have to know every step of forming these polymers. You have to have it on your fingertips. So now moving on to the next question, question number 24. Which of the following molecules is least resonance stabilized? So we just we have a pyridine here, we have benzene here, we have furan here. So we can just know in these kind of compounds, what you have here, the lone pair goes here, and it's just such a nice nice kind of aromatic compound. Benzene, you dare not to ask about it. All right, so here also this lone pair goes here, then it comes here, then again it attacks here, this bond opens up, comes here, and then it attacks here to to finally remove this bond. So the configuration changes, right? But all these compounds are having aromaticity or some kind of resonance. But in this compound, in the B part, okay, here you are having a sp3 carbon. All right, so there is no degree of freedom. This bond cannot go here, this bond cannot go here. There is no kind of total resonance of electron cloud going around this compound. So this is the least resonance stabilized compound here among the all 4 options. So here the B option is correct, the least stabilized resonance compound, or the least resonance stabilized compound, right? Okay, so now the 25th question. The increasing order of reactivity of the following halides for SN1 reaction. So what is the SN1 reaction? For SN1 reaction, you need to form first the carbocation, a stable carbocation. The stable carbocation is needed for a SN1 reaction, because in SN2 reaction, the simultaneously attack of reagent and the leaving of the leaving group takes place. In SN1 reaction, first the leaving group leaves, then the reagent attacks. So in order to have a favorable SN1 reaction, when the leaving group leaves, you have to have a stable carbocation. So let's see which of these compounds can give me a stable carbocation. So here you have CH3 and then CH, and then you kind of have a Cl here, then another carbon CH2, and you have a CH3. Right, so in this, when CHCl leaves, you get a carbocation here. This is a second degree carbocation, okay, which is fairly stable. All right, but in case of 1 2 3, all right, and then you get a Cl. In case of this compound, when this Cl leaves, you get a carbocation here, which is a primary carbocation, less stable than the secondary carbocation. In the third case, what you have, you kind of have a benzene ring here, all right, and then what you get is CH2Cl, and at the para position you get a COOH, no, sorry, CO, all right, no, you get a OCH3 right here. So what happens here in this compound, when this Cl leaves, you get a carbocation here, and this is very stable carbocation, because from the resonance of this benzene ring you get, from the double bond here, this carbocation is stabilized and it actually moves around, you know, the ortho para position. And even the, you know, the methoxy group here, right, this OCS3, it stabilizes the carbocation even further, because O can give, you know, lone pairs to this position and can take a positive charge over here, so the positive charge is even resonating here. All right, so this is like the most stable carbocation, one of the most stable carbocations you get. Sometimes in the solution Cl is just free to move, even if there's nothing to, you know, to attack on. So the third option is very stable carbocation. Then you get the first option as, because it's a secondary carbocation, and then you get the second option as, because it's a primary carbocation. So increasing order of reactivity for the following halides is, this is this increasing order of reactivity. So first the option number second. All right, so we get two options for that, then the option number first, then the option number third. So D part is correct here in this question, because we need to find out the stable carbocation for SN1 reaction. All right, okay, so now the question number 26. The major product obtained in the following reaction is, what is the following reaction? Let's look at it. So again you get this tertiary butyl, so you get right, so it's a bulky base, you know, it's a bulky reagent, very bulky reagent. So bulky reagent, what again will happen? Substitution or elimination, right? If there is any possibility of elimination, elimination will be favored. Okay, let's see. Here if Br leaves, the carbocation comes here, and do we have a alpha hydrogen? Yes, we do have a alpha hydrogen. So the alpha hydrogen leaves from here, right? And what you get? You get a double bond here. Fairly simple question. Substitution, you see the reagent, you see whether the substitution or the element, and here, you know, if Br leaves, then this carbocation is very favorable, because again it is going into resonance here. Okay, so leaving Br is also possible, and since it's a bulky reagent, so it does not want to go, like it's very hard for him to go inside the compound, and since the compound and the site which is going to be attacked is also very hindered, so it's not at all favorable for the bulky group to, you know, get inside the molecule and attack at this site. So the substitution will not be favored. What will be favored? The elimination will be favored, and elimination is favoring because there is a carbocation as well at this point. Okay, so the Br leaves, a carbocation develops, you know, this H is taken by this base, and you get a double bond here. What is the correct option? D part is the correct option. Okay, get it? All right, so moving on to the next question, which is 27th question. And now the tough part of your organic chemistry starts if you haven't, you know, read it very thoroughly. Okay, so let me, you know, solve this question for you. All right, so which of the following compound behaves as reducing sugar in aqueous KOS solution? So what the aqueous KLOS, so you know this question you can, if even if you don't know the complete reaction, you can then again solve this question by very basic common sense and the basic knowledge of your organic chemistry. So this aqueous KOS solution will react with what? Okay, you need to see it will react with what in this in this compound. This thing? No. All right, nothing else in the compound. OCS3 will not react. Okay, let's see what else was. Okay, we have ester here. All right, will it react? Yep, it will react with it. So what does it do with this? Okay, so the moment it sees one, Esther? Let me show you like how this this. Okay, let me. I guess I do have a pen here. Okay, so I should have an eraser as well. Okay, just leave it here. All right, so what happens, you have this compound, right? So you have this compound. The moment it reacts with aqueous KOH solution, right? The moment it reacts with aqueous KOH solution, you know, it removes this part from here. All right, it removes this part from here. Okay, and what does it do? It leaves you. So in aqueous chaos solution, one one. Okay, let me draw the compound. So in aqueous chaos solution, I was just trying to make sure that it is visible to you and we don't have to go through a lot of trouble, because they are like reasonably big compounds. Okay, so yep, so you again have this CH2OH here, and then you have a O, C double bond O, CH3 here, right? So in this compound, this aqueous KOH solution, so means OH minus ion. So OH minus ion directly attacks here. Okay, and this bond will come here as a negative sign, and because now this carbon is having a couple of oxygen attached. Okay, so because of now the back attack of this minus charge, this group will leave, right? That's what happens. So when it happens, then you get a C double bond O, CH3 O negative, which is this part, and then this part, the leaving part, you'll get like, right, you'll get something like this, CH2OH, and then here again OH, and then CH2OH and O negative. Again you have a carbon where you have two oxygens attached. What will happen? Because of the back attack of this oxygen, this bond ring will open, right? This whole ring, because it's a hemiketal situation, right? So now after this getting this compound, we'll have a ring opening, right? We have a ring opening situation, and when this ring opens, you get O negative here, and then in the compound which you had previously, CS2, actually these part are like really unnecessary, because they wanted to make it a sugar or something. They they kind of had this all thing. It makes the system looks complex as well, but you should understand there is nothing complex in this this question. So you get a CS2OH here. Now the compound which you are having here finally, all right, if you put a tolerance reagent, right, if you it'll give you the positive silver mirror test, right? It will give you a positive silver mirror test. So this sugar is actually a reducing sugar. When you use it in, it behaves as a reducing sugar in a aqueous QoS solution, right? And you can see the other compounds. If you have this OH minus and this aqueous QoH, where will this O negative attack? Nowhere, right? So this is the correct option for you, the C part. All right, okay, move on. So the 28th question, which is 3-methyl 2-pentene. All right, so let me draw something like this. So in the third position you have a methyl and 2-pentene, right? So on reaction with HBr in presence of peroxide, so you are going to get this anti-Markovnikov addition, right? So in this case you are having 3-methyl pent2ene, and you are going to get your anti-Markovnikov kind of addition, because it's in presence of. So what do you get here? Eventually, when this bond gets through the addition, you get a compound like this. So H will get attached here, and Br will get attached here. This is the anti-Markovnikov addition, right? The anti If you don't know it, then you haven't studied organic chemistry at all. Okay, so you should know this one. And now, as you see this thing, as this compound gets developed, so how many the number of possible stereoisomers for the product is, right? So as you see here in this compound, there are two chiral carbons being developed, right? For this carbon, this group is different, this group is different, all right, and this whole group is different, right? For this carbon, this group is different, this group is different, this group is different, and another H is different, right? Here also another H is different, right? So all four groups it has are different. So two chiral or chiral or whatever you are comfortable in it, I call it chiral, so but you can call whatever you like. So two chiral carbons are being developed. So two chiral, when a new chiral carbon is being formed, it means all possible configurations will form, and since there is no symmetry in this compound, that means that all there is no enantiomers or something, so it means that there is no like same compound. Okay, so it means that all four configurations, there is no symmetry in the compound, right? So it means all four like the total number of stereoisomers will be 4. If there would have been a symmetry, then you would have had 3 possibilities, right? So it means your option B part, which is 4, is correct, right? So now in the 29th question, the correct sequence of reagents for the following conversion will be. So you need to cool down for this question because the list of reagent is kind of long, but then again, if you let's say we start with this Grignard reagent, right? If you put the Grignard reagent in this compound, what will happen? This Grignard reagent will kind of attack here and and try to add a couple of CS3. But what will happen if you once attack with the Grignard reagent, right? You get one CS3 attacked and then you get a OH. Is that true? Okay. And what happens when you use this Grignard reagent at this carbon? Right? You get one CS3 attached to this carbon. After that, can you get another CS3 attached? No, that's not possible. So starting with the Grignard reagent is not a good idea in this compound. All right, so let's start with the Tollens reagent. What occurs if we if we just try to add Tollens reagent to this compound? Let's see what happens. So we have a CHO here, and then we have a double bond O here. Okay, and we add this reagent, which is AgNH3, right? Positive, OH negative. We add this thing. So what does it does? It converts your CHO into COOH. That's fine. Okay. So now we are at the moment we are discarding the Grignard reagent 1 because it is not living up to the desired product. So now when we start with the Tollens reagent, and now when we try to let's try to do the esterification, right? So H plus and and CH3OH, right? The esterification one. What happens in this one, in this reaction? Okay, you get a compound in which you have something like OCH3, right? Because in this the CH3O negative will attack here and it will replace, right? It will get attached to the carbon at the bottom, right? Okay, so now after this, because the normal reaction suggests the OH, the OH is there and then the H plus will attack to the OH and then forms OH2 plus, right? Here the OH is there, and this H plus will attack to the OH and creates OH2 plus. Then this CH3O negative will attack this carbon, right? And the O will have a negative charge, and because of the back attack, this H2O leaves. This is the whole mechanism of this reaction, right? Then after this reaction being possible, if we add our Grignard reagent, right, that are possible, this CS3MgBr, right, if we add it, so first if we add CS3MgBr here at the top part, so we get some O negative, right, and CS3 here. This O negative will eventually be OH, and then at the bottom part, right, at the bottom part, if we add, so let's see what happens. So the once this CS3 get attached here, you are going to get a O negative, right? And because of that O negative which you get, right, because of the back attack of this O negative, this group is going to leave. Because of the back attack of this O negative, this group will leave. And then what happens? You get a double bond here again, and then, right, so and then again you sort of, the Grignard reagent works again, and you get a CS3 here again, and then this negative charge will eventually be satisfied with OH, right? So your final compound you are getting, if you are starting with the Tollens reagent, then the esterification reaction, and then the Grignard reagent. So your option C is correct here. All right, you just have to see, like, first we started with the Tollens reagent. What did the Tollens reagent do? This CHO, it converts the CHO into COOH, and now when we did the esterification, it converted this COOH into COOCH3, right? According to the mechanism I told, the OH of the acid will be, will form the OH2, and because of the attack of this methoxy group, this OH2 will finally leave, and then you get this compound. Now in this compound, if you do the Grignard reagent reaction, then finally you are going to get a methyl group at the top and a couple of methyl groups at the bottom. Why? Because when the first methyl group will come and attack here, then that time, because of the back attack of the negative charge on oxygen, this group will leave. It's a bulky leaving group. This will leave, and then you have a double bond here again, and then when again a Grignard reagent will attack here, then you are going to get another methyl group and a OH here. So the C option here in this question is correct. Now the 30th question. The major product obtained in the following reaction is, what is the following reaction? So you are just going to react the compound. Alright, so I guess the compound is mentioned here. So the alright, so we okay, so in this compound, I guess there is some problem, so let me just rectify it for you. Okay, so the major product obtained in the following reaction. So what is the following reaction? This is your following reaction. Okay, the major product obtained in the following reaction, and then the A part of this question, which is not given here, is, right, the A part is not given. Okay, so the A part is this. Okay, yep, let me just draw the A part for you. All right, so I guess the 2 with the not 1 is there, and yep, so this is the A part for you. CHO and CHO. Yep, this is the A part for you. Okay, so the major product obtained in the following reaction. This is the reaction. This is the A part of the answer, B part of the answer, C of the answer, D. You need to find out which option is correct. So let's see what dival H does. So there is a compound given in the reaction and it is going to react with diol H. What does it do? The diol H, it converts your acid into CHO, right? It converts the acid into CHO, it converts the ester into it reduces the esters as well. Right? It reduces acid, it reduces esters, lactones, amides, carboxylic acids, everything it reduces, right? Okay, so and it gives a partial reduction. So what will happen in this case? First of all, this ester is going to reduce itself. So you'll get a H here and you'll get another H here. And this is another acid which is going to be reduced to CHO. This is what diol H does. Alright, these double bonds are not going to be reduced by diol H, it's its property. Okay, that's how it works. Alright, how does it reduce H minus ion and all? Nothing we need to know right now. We just need to know it reduces the ester and acid. Alright, and so when it reduces it, so this bond going to get opened, and what you are going to get, what you are going to, it's a 5 atom ring. What you are going to get here, you are going to get double bonds here, and then this O will have a H, right? We are breaking the bond from here, and then this will go from here, and this carbon has a double bond and it has a H, right? So basically this is a CHO, and then here this acid is going to reduce in CHO. Which is the correct option? B part? COH? No. CHO looks nice. Where is this OH? Not there. OH is there, right? CHO is there. COH? No. 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 So the A part which I drew, which was not there actually. So so by mistake in place of the A part, there was a question. Okay. So now at the A part, you have the OH, that is correct. You have CHO, that is correct. You have CHO here, that is correct. So you get the point. Diol H, what does it do? It reduces your esters, it reduces the acids, okay, and it does the partial reduction, so it doesn't reduce the aldehydes. Okay, so in the 30th question, the A option is correct. All right, so now we have discussed successfully the 2017 grade up, not grade up, 2017 JEE Mains question paper. I hope you all got the solution. If any problem, you can contact on the app, you can discuss with them. There are a lot of notes if you are revising your concepts and you need to find a good notes in formulas. You want to try a lot of tests, because this is the time for you to have a lot of test papers. And if you want to discuss your doubts with your fellow students, as well as very easily approachable experts we have to discuss the doubts and sort out your doubts and problems for you, you should go ahead and download the Google Play app right now from the Grade Up app from the Android App Store, the Google Play. You can download the Grade Up app from there, and this is the best exam preparation application you'll get. A lot of freedom and a lot of discussion is going on there. Meet your fellow students, discuss about your preparations, and prepare well. So this is Sorry Dwivedi signing off. We'll meet up in the next screencast soon. Thank you.